Okay. Alright, so let's find the one that says review. Okay, it's got a little heart with a period 5 on it. Alright, so that's the review sheet. This is one of the assignments that will be turned in. So why don't you start a piece of paper? And we'll go through this. And of course, we're going through it together, but you can always go back and redo it on your own, right? Okay, so here we go. First whole section, domain, 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 domain. All right, so the first one says, what's the domain of y equals x plus 1? The domain would be, we are so on top of it. What about the second one that says, yes, all real numbers, no fraction, no radical, no issue? What about C?
X canonical 0.
X, everything except 0. Uh-oh, D, a little bit harder.
X canonical
X is greater than or equal to 1. X can't be 4. So X can be anything bigger than or equal to 1 except 4. Because if you put 4 in, you get a 0 in the bottom, right? What about E? All real numbers. Now you're looking at it and saying, but Mrs. Ford, there's a denominator. You're right. But the only problem with denominators is sometimes they're 0. Can x squared plus 1 be 0? No. Now it would be different if it were x squared minus 1. But x squared plus 1 is always going to be positive. So E is all real numbers. What about F? All real numbers. What about G? No, 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 no. Be careful. It's x squared minus 9. So x can't be 3 or negative 3. For G, x cannot be 3 or negative 3. How about H? It's another one of these kind of tricky ones. What about H? X is greater than or equal to 2. Now, I'm not going to take points off for this, but do I really need to put that in there? I mean, you're right, it can't be, but if you've already told me it has to be bigger than or equal to 2, haven't you ruled that one out? So if you looked in the back of the book, if this was a book question and you looked in the back of the book, this is all it would say, because you don't even need to worry about the denominator then. See what I'm saying? If you're bigger than 2, you can't be negative 1/2 already. All right, find the vertical, horizontal, and holes. A. Yeah. If you don't have a denominator, you're not going to have any asymptotes. And if you don't have a denominator, you're not going to be able to cancel, so you're not going to have any holes. What does A look like when you graph it? A line. There's no asymptotes in there, just a line. B, on the other hand, does have asymptotes and things. So for B now, for problem B, vertical, horizontal, holes. What have we got?
Horizontal, y equals 1.
Be careful. What's my horizontal asymptote?
Oh, wait, you're right. 0.
Y equals 0. Very, very good. Remember, when the power on the bottom is bigger than the power on the top, you can't match them up. When the one on the bottom is bigger, the fraction is going to be getting smaller, so it's y equals 0. All right, what about vertical asymptote for B? X equals negative 2/3. Because The asymptote happens where the denominator is 0, right? That's where the asymptote happens, and that's going to be at negative 2/3. What about holes in B?
None.
None. Because the only way you're going to get a hole is if what happens in the problem? It cancels. If you can't cancel, you're not going to have one. All right, what about C? Horizontal asymptote is
Y equals 0.
not y equals 0, y equals 1. Because in B, or C, I mean, in C, we have x squared over x squared. The powers match. The big one isn't in the bottom. They match. So you have x squared over x squared. All right, what about vertical?
X equals 3.
Two of them. X equals 3 or negative 3.
No.
Two vertical asymptotes.
No.
What about holes?
None.
None. All right, now let's take a look at D. It looks to me,
Is that a square?
yeah, like we can factor the bottom, take an x out of the bottom. And what's the significance of that? Why is that? Oh, now we can cancel. So that problem is going to become 5 over x plus 4. And the fact that I canceled out an x means I'm going to have a hole, and the hole is going to be where x equals 0. A plain x. Not x plus 1 or anything like that, just a plain x, so it's at 0. Now, how do I get my y coordinate? I plug 0 back in my new problem, and I get 5/4. So this picture has a hole at 0, 5/4. Now, look here. Does it have any asymptotes?
No horizontal asymptote.
It has a horizontal asymptote where?
0.
Y equals 0. The power on the bottom is bigger. That makes your fraction bottom heavy. Fractions with big bottoms are small. 1 over 100, 1 over 1,000, 1 over 1,000,000. They're small. So 0 is your asymptote. What about a vertical? Does this have a vertical? X equals negative 4. Perfect. And then one more. I'm going to factor as I write it down. Looks like I can take out a 2x. And on the bottom, I can take out a 3. And then factor that some more. What happens?
You get a hole.
I'm going to have a cancellation, which means I'm going to have a hole. And where's that hole going to be? It's going to happen where x is negative 3. Everybody got that? And then I need my y coordinate. And where will I get my y coordinate? Plug negative 3 in here, so that's negative 6 over 3 times negative 6. Did you get 1/3? So I have a hole at negative 3 comma 1/3. This is my problem. All right, what about asymptotes? Horizontal is y equals 2/3. Look what you've got. You've got the same power on top as the bottom. So you just compare them, 2x over 3x. How about a vertical asymptote? X equals 3, because that's what the denominator can, or that's what x cannot be. X cannot be 3. or you'll end up with a 0 down there. Okay? All right, what's next? Oh, now we are graphing. These are the piecewise functions, remember? So, my guess is you're going to have to do one of these on your test. So, let's see. All right, so here we go. What shape is that top equation? X plus 2. That's a line, right? So tell me about that line. It has a y-intercept at 2 and a slope of 1. So that's pretty easy to graph. It's going to look like that. Another way to think about that is, take the 2 away, y equals x is what? Y equals x. That's your identity. You know what that looks like. When you put a plus 2 on the end, what does it do? Picks it up 2, which is exactly what happens. So that would be another strategy to sketch that. Now, I don't want the whole thing, though. I don't want the whole line. What part of that line do I want? I only want a piece of it. All right, now if I put in 1, I get 3. So this is the point 1, 3 right here. Would you agree with that? And I want, that's the important point now. And I want all the parts of the line that have x's less than that, so I don't want this. And 1, 3 is a nice solid dot, right? Because 1 is included. All right, what's that? That's another line. Y-intercept is 0. Maybe I'll do this in a different color. And its slope is -2. So that means I'll go down to another one. So it's going to look like this. But I don't want the whole thing, do I? I only want the part of it from 1 over. So if I put 1 in, I get -2. So this is the point 1, -2 right here. I'm going to put an open circle there at 1, -2. And then I only want that part of the line, so I'm going to erase this. And that is my answer.
How do you get the 4?
Plug it in. Put 1 in, 1, -2. Now, domain. I don't know that it asks that, but I'm going to. Domain is what? All reals. Right here, kids, domain is x. That's your domain. They always give it to you in a piecewise function. Your domain is right there. The range you have to figure out. So tell me about the range. Negative infinity to 3. Patty, if you want to say y is less than or equal to 3, that's fine.
Everything below 3, but interval notation.
In interval notation, in interval notation, it would be negative infinity to 3. That would be your range. All right, there's one more of those to practice. Review sheet always has more questions than the test does. So here we go. This is a 3-parter. All right, good news is you absolutely know all of these shapes, right?
Yeah.
that's a E, that's a line, and that's a parabola. So sketching this is not going to be a problem. So here's my V. I'll start with the top line. There's my V. Now, do I want the whole V? No. -2. If I put -2 in there, I get 2, right? So here's the point, -2, 2. That is the important point in this problem, right? Because they tell me right there. So is that okay with everybody? Now, am I going to keep this thing, or am I going to keep all of this over here? What am I keeping? I'm only keeping this, right? I'm going to go ahead and extend it a little farther. That's what I'm keeping. This is what I'm losing. Because the problem says you only want the part of the V that has x's less than -2. All right, what's that? That's a line with a y-intercept of 1 and the slope of 1. So it's gonna look, I have such a hard time drawing lines. It's gonna look like that. But I don't want the whole line, do I? What part of the line do I want? Only the one point where x equals -2. So the one point where x equals -2, y equals -1. Plug it in, -2, -1. That is the only point I want. So I don't want any of this stuff, and I don't want any of this stuff. I only want that one point. X equals -2. And then on to the last one. What's that?
Parabola.
That's a parabola. So it's going to look like this. Do I want the whole thing? No. Only want the part where x is -2, bigger than -2. Now, if I put -2 in, I get 4. So this point is -2, 4. And I don't want this. I only want the rest of it. Wow, what a weird looking picture.
Range is going to be a pain to do.
What?
Range is going to be a bit of a problem to figure out.
Domain is okay. What's the range?
Even with that one point.
The range is -1 to infinity.
It's just -1, then we jump to 0 to infinity.
So the 0 to infinity part, for sure, that's the parabola in this ray, right? Going from 0 to infinity. What else do I have to include though?
Y equals -1.
Y equals -1. And there really isn't an interval way of writing that. So,
Set notation?
usually when we put, yeah, set notation would work. Usually when we put interval notation, there are 2 numbers in there. So maybe we'll just write it this way. X, y, not x, y. Y is greater than or equal to 0, or y equals -1. That would be your range.
When there's more than one, do you want us to put the U or the or? Does it matter?
If you are using interval notation, you should use the U. If you're using set notation, you can use either one.
Okay.
All right, that's done. Okay, what's next?
The range. Domain.
We already did domain. Domain's all real numbers.
Confused with
All right, so now we're ready for 4. solve these equations. Oh, wait a minute. These are a little bit of review. These are from chapter P. What do you do with 4a? Well, first you get it set equal to 0, and then you figure out what you're going to do with it. Somebody said factor. This appears to factor. Of course, if you don't want to factor, or if it doesn't factor, you could do what? The quadratic formula. Yeah, but that one's done. Okay, that was easy. First thing I'm going to do is divide by 3. Get that out of there. And then you can do this however you want. You know I'm going to draw a number line. And what am I going to put right in the middle of the number line? A negative 1. And then I'm going to count 2 this way. I'll be at 1. And 2 this way. I'll be at negative 3. Less than. So I have negative 3 and 1 to 1 is my answer. The interval from negative 3 to 1. Now you may choose not to do the problem that way, and that's fine, but that's the answer you need to come up with. And then C, another little quadratic. I bet this one doesn't factor though. So if it doesn't factor, and that does not look promising, I'll use the quadratic formula. I would never, if I had a choice, which I do, I would never complete the square on this, because if you were going to complete the square, what would be the first thing you do? Divide by 5, and then you're going to be full of fractions, and who wants to mess with all that? So we'll just do negative b plus or minus the square root of b squared minus 4ac all over 2a. We got a double negative there, so we'll take care of that. Is that 61? And that's about all you can do. Easy enough, right? All right, now we got all these functions and we're doing stuff to them. Okay. So 5a, what's f of 2? 1. Just plug 2 in. 1. That's easy. What's f of x plus g of x? That's about as hard as it is, right there. That's it. What's f? Oh, wait, stop. It says, what's the domain and range? It says, what's the domain and range for this one? Okay, so what's the domain? Take a look at it. What's the domain? The domain is x cannot be 0. Don't you have a denominator here? So x can't be 0, right? That's your domain. Now, range is hard. I wonder what the range of that is. We need to graph it. Let's get our calculators out and graph it and see if that helps us at all. That's a great suggestion, Patty.
Great suggestion.
I don't know what kind of window you have set up. Start with the standard window and see if you can see anything. What you're looking for is any breaks in the picture. Because if there aren't any, it'll be all real numbers, right? And if it's going up high and down low.
Mind my eyes. It's my calculator.
Did you see when it sketched? Have you gotten it sketched? Did you see it drop in a vertical asymptote at 0? There's a vertical asymptote at 0 because x can't be 0. But then I got a picture that looked like this. So here's my asymptote. It looks something like this. And then I got like a parabola like that up here. Is that what yours looks like?
Yeah.
Okay, tell me about this piece of the curve. What does that piece of the curve appear to be doing? Going down and up forever and ever and ever. So it really doesn't even matter what's happening over here. We're going down and up forever and ever and ever. So what is our range? All real numbers. All right, C says f of negative 3 plus g of negative 2. All right, what's f of negative 3? Negative 2/3. What's g of negative 2? 8. Negative 2 squared is 4 times 2 is 8. So your answer is, let's see, this is 24/3, so 22/3 or 7 1/3. F of g of 4. This is the next question. F of g of 4. So where do we start? G of 4. We figure out what g of 4 is. What is g of 4? Right here. F of g of 4. So we're finding g of 4, and what is it? 32. And then we're going to take, so f of g of 4. G of 4 is 32. So f of 32 is 2 over 32, 1 over 16. What does E mean?
Plugging f of x into g.
Plugging f of x into g. So we're going to find g of 2 over x. So g of 2 over x would be 2 times 2 over x squared. Is that right?
Mm-hmm.
So 2 over x squared is 4 over x squared. I got 8 over x squared. Remember, that's 2 over 1. Now we want the domain and the range of the composition. So this is my composition right here. I want the domain and range of that. Now remember, when you do the domain of the composition, you don't just look at this. What else do you have to look at? The domain of the input, which for us is function f. What's the domain of f? I think we already did that. The domain of f is x can't be 0. What's the domain of the composition?
X
X still can't be 0. So what's the domain? X cannot be 0. X cannot be 0. Now the range of the composition. Look at this function right here. You should be able to tell me what the range of that is. Think about, tell me about the y values. Think of different values of x. Plug in whatever x's you want. Tell me about the y's. Let's graph it. On your calculator, let's graph it. Range is tough. I'll give you that. Range is tough. Usually if you graph it, you get a much better idea of what's going on. Yeah, so when you graph it, you got your vertical asymptote at 0. You've got a horizontal asymptote at 0, and before you say, how do you know that, where's the biggest power in the problem? in the denominator, and I've said it like 15 times today, when the big power is in the bottom, the horizontal asymptote is always going to be at 0. Now, because that's squared, everything's going to stay positive, right? Your outputs are all going to be positive because you're squaring in the bottom. So, what's your domain?
Y is greater.
Y is greater than,
0.
Not your domain, your range, I mean. Your range is Y is greater than 0.
Not equal to?
Or sensitization.
Does it ever equal 0? Will that number ever equal 0? No. Will it get closer and closer to 0? Yes, but never equal.
We can put 0 to infinity.
Yep, with a parentheses. 0 to infinity. Okay, number 6 says, know the 12 basic functions by name, equation, and graph. Okay, so you know those. We're not going to review that. You know what those are.
Turn this in, do we write them all?
No, you don't have to write anything down for that one. This is a review sheet. I'm just telling you, you need to know those things. Okay? Vocabulary. What's it mean to be even?
Symmetrical.
Symmetric about the y-axis. Odd. Symmetric about the origin. A removable discontinuity. That's when you cancel out. So in other words, Maya, that's what creates a hole. A hole is a removable discontinuity. A non-removable discontinuity then is one that doesn't cancel out. And what does that make? A vertical asymptote. So a removable is a hole. A non-removable is a vertical asymptote. All right, describe the impact of the 2 and the 3 in this equation. So what does the 2 do? Moves it 2 units to the right. What does the 3 do?
3 down.
3 down. So we're going 2 right and 3 down. Everybody good with that? Now 9 is, okay, back in number 6 it said know all the things. 9 now is making sure that you do. What shape is 9A? It is a V. Now the normal V would be coming out of the origin. But this V, what has happened to it? You're going up 2. So this V would look like this. Up 2 units. What shape is problem B? It's a parabola. It's a square, so it's a parabola. The normal parabola would be coming out of the origin. What's happened to this one? Right 1. So you've got the same parabola, but moved over 1. And you're just doing a quick sketch. Now, C, this is your sine function, which you know looks like this because you've memorized it. And you need to be able to label your x-axis. And you need to know that your y-axis just goes from 1 to -1. So that is the basic curve. I mean, that's the one you've memorized. Now, we are going to graph that. So what happens to this basic picture that you've got memorized? What happens to that now? It goes down 1 unit. So every point on the graph comes down 1 unit. So if it's easier for you, you can just literally drop the points 1 unit. So the green thing is the answer. Now you are welcome to bring a colored pencil and go ahead and do it this way, or if you just want to erase the original, that's fine too, whatever works for you best. What is the domain of the green? All real numbers, forever and ever, sine and cosine, all real numbers. What is the range of the green? Now, the range of the black is -1 to 1. What is the range of the green?
It's -2 to 0.
-2 to 0. Everything got dropped down 1. So now your highest point's at 0 and your lowest point's at -2.
Brackets?
Yes, because those points are included. Each of the functions in number 9 is bounded above, below, or bounded. Identify the bounds of each. Okay, so I've still got them graphed up here. So look at this one. Describe this one in terms of boundedness. What would you say?
Bounded below.
Bounded below at y equals 2. Bounded below at y equals 2. How about this one? Bounded below
X equals 1.
at, no,
Y
we're
equals
bounded by
y.
y. So we're bounded below at y equals 0. Remember, boundedness has to do with floors and ceilings. That's y's. All right, green. We're looking at green. What do you say about green?
Bounded.
It is bounded because it's bounded above at y equals 0 and bounded below at y equals -2. So that's another vocab word. The word bounded means you're bounded above and below. Right? And finally, number 11. Oh, this is a calculator problem. So let's get our calculators out. And we're looking for the relative maximums and minimums. So again, I have no idea how your window's set, how mine is set. I'm just going to type it in and see what I can see. So x cubed plus 4x squared minus 8x minus 32. I'm going to hit graph. Now, this time, when I hit graph, given this question, which is find the relative maximums and minimums, what do I need to see? I need to see tops of hills and bottoms of valleys. Before, I'll show you what I'm looking at right now on my screen. What I'm looking at is this. Now, if I were solving this equation, if I were looking for the zeros, this would be fantastic, wouldn't it? Because that would be these points right here. I see them, it's great. This is not good enough though. I see my max, but I don't see my min. So what adjustment am I gonna make? I'm gonna go to my window, and what one number am I gonna change? Y min. I need to go down farther, so I'm gonna change my Y min. I changed it big and it still didn't work, so I'm gonna try it again.
Okay. I found them. I mean, I should find the minimum. But it's big.
There, I got it. Okay, so finally I had to go all the way down to, I went down to -40 and that finally worked. Okay, so now we're gonna find our maximum. Let's find our maximum. So second calc, go down to where it says maximum. And then you get the cursor saying left bound, right bound. This time you're gonna set it over here. Oh, not too far. I wanna set it over here somewhere. And then I wanna set it over here somewhere. And my maximum, if I type that all in right, is at -3.44, comma 2.15. Does that look okay?
Yeah.
Now that is my relative or local maximum. that is not an absolute maximum. Would you agree with that? Because what does this curve do? There is no absolute maximum, nor is there an absolute minimum. But there is a relative minimum, so now I'll find that, start over, second calc, go down to minimum this time. We set our bounds just like we did before. This is exactly the same as you've done before, except now you're looking for high points and low points. I got 0.77, comma, negative 35.33. So the question said, find the relative maximum and minimum values. There we go.
Is there a difference between relative and local?
No. Two words for the same thing. All right, now do B on your own real quick and we'll be done with this sheet. I heard somebody out there saying there's no max because it's a parabola. Whoever that was, right on target. It's an x squared equation. What does an x squared equation always look like? A parabola. It's either going to have a max or a min depending on which way it opens, but it's only going to have one or the other. My minimum, I got 1, negative 2. Did you? All right. So Mrs. Ford has just done the review sheet for you. All right. Again, when it comes time to turn this in on test day, you can turn in the work that you just did. But I would suggest that, especially if I did something that you're a little bit hesitant on, that you go back and redo it on your own. Okay? I see you one more time, and then we